Okay, for the second problem, right? The second problem is, let me just try to check these things. The second problem is this problem right here. So if it's the sideway, you need to open it with different image viewers. But you actually drink the 400 milliliter of ice water at 0 degrees Celsius, and then see how much of the heat is actually taken off from the body. That's the first step. The other one is that what happens if you actually sweat out 400 milliliters, the same amount of the water vaporized from your skin at 37 degrees Celsius? What's the heat loss associated with that? So there are two different programs. The answer is already here, but we are going to try to do the same problem with the Excel to see that whether you actually get exactly the same number or not. Idea is something. Isn't this supposed to be the 4.01? Yeah, I think it's a 4.01 something. Yeah, let me just try to go to the not this. Yeah, it's this one, right? It's 4.184. What did it say? So yeah, 4.184. Oh yeah, right. So it was supposed to be 4.184. I just noticed that one. So please fix the first videos after you watch this. Alright, so so the actual answer is going to show up as 265. That's the correct answers. The beauty of the Excel is that later on you change this number, it's going to automatically change everything. So see, so you don't even have to do anything. So that's that. Alright, so what happens for the question number 2? So let me just try to write it in some around here. So the question number 2, you have 400 grams of water. Now for the, I don't want to change this number because it's going to change this number too. So mass of water for Q2, that's 400 milliliters, but 400 milliliters is pretty much 400 grams, so I'm gonna put it as a gram. Then for the question number 2, the same stuff here, right? Specific heat times the mass times the change in temperatures. So the heat required, heat loss by drinking the 0 degree Celsius ice water is specific heat of water multiplied by the mass multiplied by the delta T. Right? So I'm gonna do that, which is equal to specific heat of water multiplied by the mass of the water multiplied by the temperature change. For this particular case, you're going from the 0 degree to 37 or the 37 to 0, depends on the point of view for the water or the point of view from the body. So but this particular case, it's we're dealing with mass of water is 400, right? So we're dealing with the water. So you have to think of yourself as the ice cold water. So ice cold water started out with 0 degree Celsius, it's gonna end up as a 37 degrees Celsius. So the final temperature is just 37 minus 0 degrees Celsius. I just typed in these numbers, but you can actually put it into somewhere around here if you want to, but it's pretty much the same stuff. So that's the joule that's being lost by the body. Now for the second way is to removing the heat from the body by sweating it, right? So sweating it is you're converting the liquid sweat to the gas phase water, right? So we are going to use this number right here. So this is the second way. It's the second heat by sweat. I feel like I'm actually maybe missing A. Probably. It's okay. You understand. Alright, so for this particular case, the heat loss is actually the delta H of vaporizations multiplied by mass, right? So the delta H of vaporization is actually this guy multiplied by mass of water. That's it. Joule. It looks like that this number is much bigger than this number. So sweating is gonna be more effective to cool down your body than drinking 400 milliliter of ice cold water. But when you actually drink the water and then you sweat everything, then the total heat that's lost by the body is going to be this number plus that number. That's pretty much all I have to say about this.